Okay, so today we're going to take a deep dive into web components, which promise this like future where we can build web apps and like not have to rely on these big JavaScript frameworks. So we're going to explore whether they actually live up to the hype. Can web components really replace these frameworks like React and Vue? And we've got a bunch of articles and some really interesting developer discussions to kind of help us figure that out. Now, this is relevant to you whether you're a seasoned developer or just starting out, because understanding this stuff, these web components, it could give you a real edge in the web development world, which, as we know,
Yeah.
changes all the time.
Yeah, and it's really fascinating how web components, they leverage these features that are already built into the browser to create these reusable, these self-contained pieces of user interface. It's kind of like it's
Oh,
almost like having a set of Legos, but like
uh,
specifically for web development.
I like that. That's a great analogy. But before we get too far into like why web components, maybe we should rewind a little bit and talk about, what we have now with JavaScript frameworks. They've done some good things for the web, right?
Oh, absolutely. I mean, frameworks like, React, Vue, Angular, they've brought a lot of standardization and made it so much faster
Yeah.
to build these really complex web applications. They essentially gave developers these like blueprints and best practices to follow, which
Yeah.
has just led to this huge leap forward in what we can build on the web.
Yeah, so they've been super useful, but like anything, I guess there are some downsides. And those downsides are kind of part of the reason why web components are getting so much attention now. One that I keep hearing about is this idea of framework lock-in. Can you explain what that means and why it's a problem for developers?
Yeah, so framework lock-in is this feeling of being stuck
Mm.
with a specific framework once you've like invested all this time and effort into building your app with it. And then if you want to switch to something else later on, it can be a huge pain, almost like you have to rebuild everything from scratch. Imagine, spending months perfecting a component library in React and then deciding, what, we actually want to switch to Vue now. Well, guess what? You basically have to rewrite that entire component library. That can be a real roadblock.
Yeah, that sounds super frustrating. And then on top of that, there's the performance issue. Frameworks can often add, these extra layers of complexity, which can slow things down, right?
That's true, yeah. Well, frameworks are really good at making development faster. They do introduce some overhead, particularly with how they manage updates to the UI. Now, this overhead might not be super noticeable in smaller apps, but as your application starts to grow, it can lead to these performance bottlenecks, especially in situations where every millisecond really matters. Like, real-time data visualization or these highly interactive mobile experiences.
So it seems like frameworks aren't perfect. They've got these downsides. Are there any others that you see developers grappling with?
Well, one more would be this idea of dependency bloat. Frameworks often rely on this whole ecosystem of external libraries and tools. And just keeping track of all these dependencies and making sure they all work together can become a real headache. Every time a framework gets updated, there's a chance it could break things. And then developers are kind of at the mercy of the framework maintainers to fix those compatibility issues.
Yeah, and I can see how that would be a big problem, especially with larger projects. And, for somebody just starting out in web development,
Yeah.
having to learn all the ins and outs of a specific framework before even getting to the core concepts of JavaScript itself, that can be a pretty daunting task.
Absolutely. And that's kind of where web components come in. As a potential alternative, they leverage the power of vanilla JavaScript, so like the core language of the web, along with this set of browser-native technologies, custom elements, shadow DOM, and HTML templates.
Okay, so let's unpack those terms a little bit. Custom elements, if I understand this correctly, they basically let us create our own HTML tags, right? So instead of using a generic div or span all the time, we can have something like my custom button.
Exactly. You get it.
Okay, what about shadow DOM?
So Shadow DOM, it's this really cool mechanism that allows you to encapsulate the styles and the behavior of your web components
Hmm.
so that they don't mess with other parts of your page. And this solves a very common problem that developers run into, which is CSS conflicts, where you have styles from one part of your application bleeding into another and causing these unexpected visual issues. It's kind of like giving each web component its own little sandbox to play in.
So it helps keep things organized and predictable. I like it. And finally, HTML templates.
So HTML templates, these let us define reusable blueprints for our web components. It's kind of like, think of them as cookie cutters for your UI elements.
Yeah.
You define the structure and content of your component once, and then you can reuse it as many times as you want throughout your application.
Got it. So we define the structure with HTML templates. The styling and behavior is encapsulated with shadow DOM, and we give it a custom name with custom elements. And the big deal here, and why people are so excited about this, is that all of this happens natively in the browser. So you don't need this big, bulky framework to make it work.
That's the key. It says native browser support. It's a really big deal. It's this shift from relying on these external frameworks to actually leveraging the built-in capabilities of the web platform itself.
Yeah, I've heard a lot about this idea, this phrase, this build once, use anywhere. And I think it's a really intriguing concept. One article we have here uses the smart drop-down component as an example. And they're saying that you could build this component once with web components. And it would work seamlessly across all these different frameworks like React, Vue, or even just on a plain old HTML page. No more compatibility headaches, which sounds amazing.
Exactly, yeah. And then it also leads to performance gains because web components don't rely on a virtual DOM, which is, it's this thing that a lot of frameworks use to manage updates, but it can sometimes slow things down. So web components can offer this nice performance boost, especially in applications where speed is really critical.
And it seems like it could simplify maintenance too, because you're building on top of these, these stable, standardized web platform features. Instead of a framework that could change with every update, you're not as vulnerable to those changes breaking your code.
That's right. You're essentially building on the bedrock of the web, which tends to evolve much more slowly and predictably than, the fast-paced world of JavaScript frameworks. So that means you spend less time fixing broken code and more time focusing on building great features.
And this approach seems like it could really encourage a deeper understanding of the fundamentals of web development. Because instead of jumping straight into a framework, you're forced to learn and use vanilla JavaScript, which can make you a much more well-rounded developer.
It's a really good point, yeah. Working with web components often requires a more thorough understanding of how the browser actually works.
Yeah.
And how to manipulate the DOM directly. It's kind of like, learning to cook from scratch before relying on these pre-made meal kits. You gain a deeper appreciation for the ingredients in the process.
So you mentioned that web components are built using this vanilla JavaScript. Can you walk us through like a real-world example? What does the code actually look like?
Sure. Let's take a look at OJ. There's this code snippet in this article for building a notification badge, which is, a pretty common UI element you see on websites all the time. And the solution that they present here is actually surprisingly simple and elegant. You define a custom element, let's say notification badge. You use a bit of JavaScript to manage the badges count, and you style it up with a little bit of CSS. And that's it. You're done. No need for this bulky framework code or external libraries.
That does sound pretty straightforward. It would be interesting to see how that compares to building the same thing using a framework. I imagine the web component approach would be much leaner.
In many cases, yes. Frameworks tend to have their own sort of way of doing things, which can add these extra layers of code and complexity. With web components, you're really working directly with the browser's native capabilities, which can lead to, more concise and efficient code.
Okay, so we've got a good sense of the what and the why of web components. Let's maybe move on to a slightly more technical aspect, but one that's really important to understand. And that's the difference between attributes and properties in the context of web components.
Yeah, this is definitely where things can get a bit tricky. But it's this really fundamental concept that underpins how web components work. So attributes are these values that you set directly in the HTML tag of your component, whereas properties are managed within the JavaScript code of your component.
So if I've got a custom element called my component, and I set an attribute, like my component named John Doe, that name attribute is something I define right there in the HTML. But the property, which might also be called name, is handled within the JavaScript code associated with my component.
You got it. Okay.
It's a good analogy to think of attributes as like the initial settings on a device. So, when you buy a new phone, it comes with certain pre-configured attributes like storage capacity, screen size. These are set at the factory, and they're kind of reflected in the device's specifications. Properties, on the other hand, they represent the current state of the device. So as you use your phone, its properties change, battery level decreases, you install apps, download files.
So attributes are like the blueprint, and the properties are the actual dynamic state of the component as it runs in the browser. And I imagine there are some quirks to watch out for, especially with how Boolean attributes work in web components. Oh yeah, for sure. Boolean attributes, which are, attributes that are either true or false. They have some special considerations in web components. So the presence of the attribute itself usually means that it's true, even if you don't explicitly set a value. For example, if you have an input element. With the disabled attribute, it's disabled even if you just write input disabled without specifying disabled true.
Yeah.
However, when you start manipulating this attribute with JavaScript, you need to be aware of how truthiness and falsiness are represented. And our source material here uses the hidden attribute as a good example of this.
So understanding the nuances of how attributes and properties interact, it's pretty crucial for building web components that actually behave as expected. Now, the next topic I want to touch upon is this idea of reflecting properties to attributes. Can you shed some light on what that means and why it's important?
Reflecting properties to attributes basically means making the internal state of your web component visible to the outside world by synchronizing it with its attributes. It's like providing a window into the inner workings of your component.
So it's kind of bridging the gap between the encapsulated world of our web component and the rest of the application. What are some practical reasons why we'd want to do this? Like, when would it be useful to expose that internal data of a component?
Let's say you've built a custom progress bar component using web components, and you have a property within your component called value, which represents the current progress, maybe a number between 0 and 100. Now, what if you want to use that value elsewhere in your application? Perhaps to display it in a different format or to trigger some action based on the progress. Well, that's where reflecting that value property to an attribute would be really handy.
I see. So by reflecting that value property, we're making it accessible to other parts of the application that might need to read or react to it. The source material mentions using getters and setters to achieve this reflection. Can you explain how those work and why they're important in this context?
Yeah, so getters and setters, these are special methods in JavaScript that allow you to control access to the properties of an object. So a getter acts like a read-only window into the value of a property, while a setter allows you to update the property's value. But you can potentially enforce certain rules or validation in the process.
So if we used a setter for our value property, in that progress bar example, we could make sure that the value always stays within that valid range of 0 to 100. If somebody tries to set it to, 150, the setter could either clamp it to 100 or throw an error. Sounds like a good way to help maintain consistency and prevent unexpected behavior.
Exactly. Getters and setters give you this really fine-grained control over how properties are accessed and modified. And in the context of reflecting properties to attributes, they're kind of like the key mechanism for keeping the attribute and the property in sync. So whenever the property changes, the setter updates the corresponding attribute, and vice versa.
It sounds like clear documentation is really essential when building web components that use reflected properties. Because if other developers are going to be using our components, they need to understand which properties are reflected, how to access them, and what rules the setters might enforce.
Absolutely. Clear and concise documentation is crucial for any reusable component. But it becomes even more important when you introduce that added complexity of reflected properties. Developers need to understand the contract between the component's internal state and its external representation as attributes.
Now, you mentioned that there can be some pitfalls when reflecting properties to attributes. What are some of the things that developers should watch out for?
Yeah, one common mistake is trying to reflect complex data structures, like objects or arrays, directly to attributes. And it's important to remember that attributes are fundamentally strings. You can't just stuff an entire JavaScript object into an attribute. If you need to pass complex data between your components, it's usually better to stick to properties and use other mechanisms like events or shared data stores to communicate that data.
Right, trying to cram an entire object into a string attribute, that just wouldn't make sense. It's like trying to fit a square peg into a round hole.
Exactly.
Properties are much better suited for handling that complex data, whereas attributes, it's best to keep those simple.
Yeah, that's a good way to put it. And another important point to remember is that reflecting properties to attributes isn't always necessary. Don't feel obligated to do it just because you can if your component's data is purely internal and doesn't need to be accessed or manipulated from the outside. There's really no need to introduce the complexity of reflection.
So it's about choosing the right tool for the job. Speaking of tools, events are another really crucial aspect of building interactive web components. And we've got this great article here that uses a to-do list as an example to kind of illustrate how events work. You've got those checkboxes, the add task button. Wow. These things all trigger events that our component needs to handle. Can you walk us through the core ideas behind event handling in web components?
Sure. At its core, event handling, it's about listening for specific events that occur in the browser, like a button click or a mouse movement, and then responding to those events with JavaScript code. So when the user interacts with your web component, it generates these events. And you can write code that listens for those events and then takes some action accordingly.
So in that to-do list example, When the user clicks the Add Task button, our component needs to listen for that click event, capture the task description that they've typed in, and then add that new task to the list.
Exactly. It's like this classic example of event-driven programming. Your component is just sitting there passively, listening for these events, and then it springs into action when a relevant event occurs. And one of the neat things about web components is that they allow us to create our own custom events, in addition to using the standard browser event.
Custom events, what are those and why would we want to use them?
Custom events are a way to create your own events
Mm-hmm.
that are specific to your web component. So let's say in our to-do list example, we want to notify other parts of the application. Whenever a new task is added, we could create a custom event called task added and fire it from our web component whenever a new task is successfully added to the list.
So it's like our component is broadcasting a message to the rest of the application, hey, a new task has been added. And other parts of the application that are interested in this event can listen for it and respond accordingly.
Exactly. It's this really cool way for different parts of your application to communicate with each other without being too tightly coupled. And remember that detail property we talked about earlier, it actually plays a crucial role here too. When you fire a custom event, you can use detail to pass along any relevant data with the event.
So in our to-do list example, when we fire that task added event, we could include the ID of the newly added task or any other information about the task. That might be useful to the listeners of that event.
Exactly. It's a really powerful way to make your custom events more informative and context-aware. Now, another important concept to understand when you're dealing with events is this idea of event bubbling and capturing. This determines how events propagate through the nested structure of your HTML.
Okay, let's unpack that a little bit. I know that, HTML documents are structured like a tree, right? With elements nested inside other elements. So how does that tree structure affect how events are handled?
Imagine you have a button, and it's nested inside a div element, which itself is nested inside a form element. When the user clicks that button, the click event doesn't just happen in isolation. It actually travels through this hierarchy of elements.
So the event doesn't just fire on the button itself. It somehow involves the div and the form as well.
That's right. In what's called the bubbling phase, the event first triggers on the innermost element, which is the button in this case, and then it kind of bubbles up through its ancestor elements. So the div and then the form. And this allows elements that are higher up in the hierarchy to potentially listen for and respond to events that happen within their children.
So it's like these ripples spreading out from the point of impact, and I'm guessing capturing is kind of the reverse of that process.
Yeah, so in the capturing phase, the event starts at the outermost element, the form in our example, and works its way down the hierarchy towards that target element, the button. Now, capturing is less commonly used in everyday development, but it can be useful in certain scenarios where you want to intercept an event before it reaches its intended target.
Now, this all seems fairly intricate. Are there any, gotchas to watch out for when dealing with events in web components, especially given the shadow DOM and its tendency to, encapsulate things? Does the shadow DOM affect how events work?
That's a great question. One key thing to remember is that, by default, events that originate from within the shadow DOM of a web component, they don't automatically bubble up into what's called the light DOM. So that's the regular HTML document outside of the component.
So if I have a button that's inside the shadow DOM of my web component, and I have an event listener that's attached to its parent element in the light DOM, that listener won't be triggered when the button is clicked.
That's right. That's by design to ensure encapsulation. The shadow DOM is meant to keep the internals of your web component separate from the rest of the page. However, there are times when you might want events from the shadow DOM to be accessible to the outside world.
So how do we bridge that gap if we need to? How can we allow events to escape the shadow DOM?
So when you fire a custom event from within your web component, you can set the composed flag to true, and this will force the event to bubble out of the shadow DOM and into the light DOM, allowing elements outside the component to listen for and respond to it.
So it's kind of like punching a hole through the shadow DOM's encapsulation for specific events that need to reach the outside world.
Exactly.
That makes sense. It gives us this really fine-grained control over how events flow in our web component architecture.
Yeah, you have the power to decide which events stay contained within the shadow DOM and which events are broadcast to the wider application.
Now, I'm curious, are there any tools or libraries out there that can help simplify event handling in web components? It seems like there could be some repetitive patterns, especially when dealing with custom events and the shadow DOM.
Yeah, you're right. And thankfully, there are quite a few libraries that aim to streamline event handling, often by providing abstractions and utilities that reduce boilerplate code
Mhm.
and make it easier to work with those complex event flows.
That sounds really helpful. What kinds of features do these libraries typically offer?
They might provide features like declarative event binding, which allows you to associate event listeners with elements using HTML attributes rather than writing JavaScript code. Or they might offer event delegation, which lets you attach a single event listener to a parent element that can then handle events from all of its descendants, which can really simplify event management in complex DOM structures.
So these libraries can really boost our productivity and
Yeah.
help us focus on the core logic of our components, rather than getting bogged down in the details of event management, which sounds like a big win.
Exactly. Yeah, they often make event handling more readable, maintainable, and less error-prone.
Okay, so now that we've covered events in some detail, let's maybe shift gears a little bit and talk
Yeah.
about one of the practical realities of web development, browser support. We live in a world with so many different web browsers out there, and making sure that our code works consistently across all of them, it's this constant challenge. What's the situation like for web components?
Thankfully, browser support for web components is pretty good these days. All the major modern browsers, so Chrome, Firefox, Safari, Edge, they all have native support for the core web component specifications. So this means you can start building with web components today, and they'll work as expected for the vast majority of users.
That's fantastic news. It's always really encouraging when a new web technology comes along, and it has good browser support from the start. But what about those users who might still be using older browsers? Are they out of luck?
Not necessarily. So while native browser support is always ideal, we do have this fallback solution for older browsers, and that is polyfills. Polyfills are basically JavaScript libraries that emulate the missing features of web components in browsers that don't natively support them.
So polyfills act as this bridge, allowing us to use web components even in those browsers that haven't quite caught up yet. That's good to hear. I'm guessing using polyfills adds a bit of extra complexity to the development process.
They do add some overhead, yeah. But the good news is there are these well-maintained polyfill libraries available that take care of most of the heavy lifting for you.
Yeah.
You usually just need to include the polyfill library in your project,
Yeah.
and it will automatically detect which features are missing and provide the necessary emulations.
That's good to know. So we can confidently use web components knowing that we have these solutions in place for older browsers. Now, before we move on to our final discussion point, are there any resources or best practices that you would recommend for developers who are just eager to start exploring web components?
Oh yeah, for sure. The Mozilla Developer Network, MDN, Web Docs. They're a fantastic resource for learning about web components. They have comprehensive documentation on all the core specifications with clear explanations and practical examples. And there's also tons of tutorials, blog posts, even dedicated communities online where developers share their knowledge and experiences with web components.
It sounds like there's this whole ecosystem waiting to be explored. It's always a good sign when a technology has, a vibrant and active community around it.
Yeah, definitely. This active community is a testament to the potential and growing popularity of web components. Okay, so for our final discussion point, let's circle back to that big question that we started with. Are frameworks really doomed? Are web components going to completely replace frameworks like React, Vue, and Angular?
Yeah, it's the ultimate showdown. Web components versus the frameworks. What's your take on this, especially given everything we've learned today?
Well, it's not quite as simple as one replacing the other. Frameworks, they still have a very important place in web development, especially for building large, complex applications. They offer these really robust solutions for things like state management, routing, and data fetching, which are all features that can be a lot more challenging to implement with web components and vanilla JavaScript alone.
So it's not really a matter of one being better than the other. It's more about understanding the strengths and weaknesses
Right.
of each approach and choosing the right tool for the job.
Exactly. For many projects, particularly those where performance and maintainability are really important, web components could be a fantastic choice. They offer this leaner, more efficient approach that leverages the power of the web platform itself. But for applications with complex state management requirements, or where you have large teams of developers who need the structure and guidance that a framework provides, sticking with a framework might be the more pragmatic choice.
So the key takeaway here is to be informed. Evaluate the options carefully before making a decision. Before you just jump headfirst into a framework, consider whether web components and vanilla JavaScript could be a good fit for your project. And if you do decide that a framework is necessary, choose the one that best aligns with your project's needs and your team's expertise.
That's a great way to sum it up. Don't get caught up in the hype or the latest trends. Take the time to understand the tools that are available to you, weigh the trade-offs, and make informed decisions that are going to set your project up for success.
That's excellent advice. Now, one of the articles that we haven't discussed in detail yet, it dives into some of the nuances of working with web components, particularly when it comes to integrating them with native HTML forms. And forms are really the backbone of so many web applications. So this seems like a pretty crucial area to explore. What are some of the challenges that developers face when trying to use web components with these more traditional forms?
So one of the main hurdles is that,
Yeah.
at least for now. You can't directly extend native form elements like,
Right.
input, select, did, or button using custom elements.
Hmm.
And this limitation stems from the way browsers handle form submission and validation, which is really deeply intertwined with these built-in form elements.
So if I want to create a custom input component using web components, I can't simply extend the input element and add my own customizations.
Not directly, no. You can certainly create these custom input components, but you can't directly inherit from that native input element. There are workarounds, but they often involve creating a wrapper element that contains a native input within its shadow DOM. And this approach can lead to some complexity when it comes to event handling, data binding, and ensuring that your custom component behaves consistently with the expectations of form submission and validation.
So it sounds like this is one area where web components are still, a bit rough around the edges. Are these limitations something that are inherent to the web component specifications, or are there efforts underway to address these form-related challenges?
Well, the good news is the web development community, they're actively working on solutions to improve this whole integration of web components with native HTML forms. And one promising development is something called the Element Internals API.
Element internals. Okay, that sounds interesting. Can you tell us more about that? Like, what is it, and how does it aim to solve these form-related issues?
So Element Internals, it's this relatively new API that provides a way for custom elements to interact more directly with the internal mechanisms of form elements. It basically allows developers to programmatically set the value of a custom form element, trigger validation, and even listen for form-related events like submit and reset.
So it's like giving our custom form elements a backstage pass to the inner workings of the form so they can play by the same rules as the native elements. Does that mean we can now create these custom input components that behave exactly like regular inputs when it comes to form submission and validation?
That's the goal, yeah. Element Internals gives developers a lot more control and flexibility when they're integrating web components with forms. However, it's worth noting that Element Internals is still relatively new, and browser support isn't quite universal yet.
So we might still need to use polyfills or fallbacks for browsers that don't yet support element internals.
That's right. But it is exciting to see the progress being made in this area. Element Internals really has the potential to remove a major barrier to the wider adoption of web components, especially for those form-heavy applications.
While we wait for element internals to become more widely supported, are there any practical tips or best practices that developers can follow when working with web components and forms today?
One approach is to embrace a more JavaScript-driven form handling strategy. So rather than relying solely on the browser's built-in form submission mechanisms, you can use JavaScript to capture the form data, validate it, and then send it off to your server.
Okay, so we're taking this more hands-on, proactive approach to form management, using JavaScript to really handle those interactions.
Between our web components and the form itself.
Exactly. This approach gives you a lot more control and flexibility, and it often aligns really well with the component-based architecture that web components encourage. You can encapsulate all of your form logic within your web components, making them truly self-contained and reusable. Well, this has been a fascinating deep dive into web components. It's clear that they have the potential to really change the way we think about and build web applications. And while frameworks are certainly not going away anytime soon, web components offer this really compelling alternative for many projects, encouraging a return to the fundamentals, a focus on interoperability, and this whole world of exciting possibilities for creating truly modular and reusable web experiences.
I totally agree. It's a really exciting time to be a web developer. We have more tools and technologies available to us than ever before. The key is to just stay informed, explore all the options out there, and choose the approaches that best fit the specific needs of your projects. And most importantly, have fun building amazing things for the web.